Now let us start solving the wave equation. As I said, the wave equation is dou square u by dou t square is equal to c square dou square u by dou x square with the initial assumptions u of 0 comma t equal to 0 and u of l comma t is also equal to 0. Both the endpoints are not moving at any time. And the initial position is f of x, that is u of x comma 0 equal to f of x. And the initial velocity is g of x, ut of x comma 0 is equal to g of x. We are using the method of separation of variables to solve the wave equation. Okay, so the first step is to assume that the solution u of x comma t is a product of two functions x of x and y of t. Now we have to substitute the derivative in the wave equation. It is the second derivative of u with respect to t. So your x will be treated as a constant in that procedure. So dou square u by dou t square is equal to x of x into second derivative of y. So y double dot. So this is x y double dot is equal to, similarly, c square into, this will be x double dash y, because the derivative of u is with respect to x is taken twice. Now you separate it into two sides. Since the capital X is a function of small x and capital Y is a function of t, you can separate x to one side and t to other side. So x double dash by x is equal to y double dot by c square y. Since now this side contains only x and this side contains only t, and x and t are independent variables, the two expressions should be the same and should be equal to some constant expression. So k. There are three possible cases: k positive, negative, or 0. Before proceeding, let us see what these initial conditions mean. u0 t equal to 0. Now, as per our assumption, u at x comma t is equal to x of x into y of t, right? So u of x comma t is x of x into y of t. So what is u0 t? It is nothing but x of 0 into y of t. So if I put the condition u0 t is equal to 0 for all t, this is one of the initial conditions. So this forces that this must be equal to 0. So that means since this is a product, either this should be equal to 0 or this should be equal to 0. Now this is just a constant. X of 0 is a constant and y of t is a function. It is the entire function y of t because it is true for all t. So there are two options. Either the constant x of 0 can be 0 or the function y of t can be 0. Now what happens if the function y of t equal to 0? Y of t equal to 0 means y becomes a 0 function, right? That is, y vanishes. Now if y vanishes, what will happen? U is equal to x into y. So u also will vanish in that situation. So that means the string is a dead string. So the condition u of 0 comma t equal to 0 forces us to have x of 0 equal to 0 because there are only two options and we have disposed to this second option. So it should be x of 0 equal to 0. Now from this also you can see that the second condition was u of l comma t equal to 0 for all t. This condition forces x of l equal to 0. Thus u of 0 comma t equal to 0 implies x of 0 equal to 0 and u of l comma t equal to 0 implies x of l equal to 0. Now let us consider the first case, k equal to 0. So in that case what happens is x double dash by x is equal to 0. And that implies x double dash is equal to 0 and that implies x is equal to c1x plus c2. If you just integrate it twice, you get that. Now as I said, the first condition implies that x of 0 equal to 0. So when you put small x equal to 0, capital X equal to also 0. So 0 is equal to 0 plus c2 and that forces c2 equal to 0. Now the second condition, thus your capital X is now, so your c2 is equal to 0, so this has been gone. So your capital X is equal to, capital X of x is equal to c1 into small x. Now the second condition, x of l equal to 0 implies c1 into l is equal to 0. And there are two options, either c1 can be 0 or l can be 0. What is l? L is the length of the string. So l cannot be 0. So c1 must be equal to 0 and hence this c1 also vanishes. So what happens is x of x becomes a 0 function. So k equal to 0 gives a dead string, where the string is not moving, because whenever x is equal to 0, u is the product of x and y, right? So u equal to x into y, so that's equal to 0. So displacement is 0 at every instant of time at every point. So it's a dead string. So this is not a desirable case. Now moving on to the second case, when k is positive, you take k is equal to alpha square in order to avoid root. K equal to alpha square, and you can assume alpha is strictly greater than 0, because alpha equal to 0 means you are landing up in the case 1. So here x double dash by x is equal to alpha square, and that implies x double dash is equal to alpha square into x. So that is the auxiliary equation is going to be m square minus alpha square equal to 0. So the roots are real and distinct. We have x is equal to c1 into e raised to alpha x plus c2 into e raised to minus alpha x. This is a second order ordinary differential equation which is linear and has constant coefficients. Now in the solution, I am again putting the condition u of 0 t equal to 0. That means x of 0 equal to 0. So that implies what? 0 is equal to, I am putting x equal to small x equal to 0, and that time capital X is also becoming 0, means is c1 plus c1 into e raised to 0 plus c2 into e raised to 0. So you get this equation c1 plus c2 equal to 0. Now the second condition, x of L equal to 0, implies you are substituting capital L for small x. So you get c1 into e raised to alpha L plus c2 into e raised to minus alpha L is equal to 0. So you have two equations here, and you can find what is c1 and c2 from these two equations. You just multiply the first equation with e raised to alpha L and subtract, and that will give you c1 equal to 0. And putting that c1 equal to 0 here, you get c2 is also equal to 0. So in that case, capital X is again becoming 0 plus 0. So x becomes 0, and therefore u is equal to 0 into y. So that is u equal to 0. Again, there is no vibration at any instant of time and at any point. Therefore, the situation again reduces to the dead string situation. So this is also not desirable. The fruitful solution to the wave equation comes from the third case, that is k is negative. So you can put k is equal to minus of alpha square, where alpha is a positive number. So x double dash by x is equal to minus of alpha square. That implies x double dash is equal to minus alpha square x. X double dash plus alpha square x is equal to 0. So the auxiliary equations becomes m square equal to minus of alpha square, which gives m equal to plus or minus alpha times I with real part as 0. Okay, so the solution becomes x of x is equal to e raised to 0 x into c1 cos alpha x plus c2 sin alpha x. Okay, now we want to find what are this constants c1 and c2. For that, you can put the conditions u of 0 t equal to 0 or x of 0 equal to 0, and that if you put, you get 0 is equal to where x is equal to 0, right? So you have cos 0 is equal to 1, therefore c1 must be equal to 0. So now your capital X becomes 0 plus c2 into sin alpha x. This is now your capital X. Now the second condition, u at L comma t equal to 0 implies x of L equal to 0. So that if you put here, you get 0 is equal to c2 into sin alpha L. Okay. Now there are two options, either c2 can be 0 or sin alpha L can be 0. Now if c2 is equal to 0, already c1 is 0. Now if c2 is also becoming 0, what will happen? X will be completely vanishing, because c1 equal to 0 and c2 equal to 0 will force x equal to 0. So you cannot have c2 equal to 0. So c2 is not equal to 0. Therefore sin alpha L must be equal to 0. Sin alpha L equal to 0 means alpha L will be an integer multiple of pi. So alpha L is equal to n pi for each n equal to 0, 1, 2, 3, etc. Now this alpha L, of course you can have n equal to plus or minus integer values, but here what happens is alpha is a positive number, right? Alpha is positive and L is the length of the string, so that's also positive, so n cannot be negative. So n can be either 0, 1, 2, 3, etc. Only positive values. Here alpha will become n pi by L. Alpha is equal to n pi by L, and therefore your x of x is now c2 into sin alpha x with alpha equal to n pi by L. So x of x is equal to c2 sin n pi by L x for each n. Now we find the solution for y. So x of x is a non-zero function now. Now for getting the solution for y, we consider the second ordinary differential equation, that is y double dot by c square y equal to minus alpha square, or y double dot is equal to minus alpha square c square y. So the auxiliary equation becomes m square plus alpha square c square equal to 0. So the roots of the auxiliary equation are plus or minus root of alpha square c square I. So alpha c I. What is alpha? Alpha is nothing but n pi by L, right? So the auxiliary equations roots are going to be plus or minus I n pi by L c. And therefore y of t can be written as y of t is equal to e raised to 0 t into some constant. That constant I am taking as b1. b1 cos n pi ct by L plus b2 sin n pi ct by L. Because the auxiliary equations roots are complex conjugates and its real part is equal to 0. So e raised to 0 t comes. Y is a function of t, okay. So the variable should be t here. Thus the solution of the wave equation can be given by u of t is equal to x of x into y of t, or y of t into x of x. If you multiply, you can see that the c2 into b1 will become another constant, and the c2 into b2 also becomes a single constant, which I call it as a and b. So uxt can be written as a into cos n pi ct by L plus b into capital B into sin n pi ct by L. Now you can see that this gives not only one solution, it gives a solution for each value of n. For n equal to 0 you get 1 uxt, and for n equal to 1 you get another uxt, and so on. You get infinitely many uxt's. So I call those solutions as u0 xt, u1 xt, u2 xt, etc. And also what you should observe is these constants are constants for a fixed n. So the constants also change when you make n equal to 0 and n equal to 1, etc. So the constants a and b will be becoming a0, a1, a2, a3, etc. and b's are also changing. So you can write uxt as unxt equal to, because uxt are so many uxt are there, I am calling them as unxt. So unxt is equal to an cos n pi ct by L plus bn sin n pi ct by L into sin n pi x by L for each n. But you know that for a homogeneous equation, of course this wave equation is a homogeneous equation, the sum of solutions is also a solution. So all this unxt, if you sum it, you get another solution that you can prove that that's a solution to the problem. So uxt is taken as the total summation of all these unxt. So uxt, the most general solution of the wave equation, is going to be uxt equal to sigma n equal to 0 to infinity an cos n pi ct by L plus bn sin n pi ct by L into sin n pi x by L. And this is the most general solution, and from this you can derive particular solutions. Now I have not used the assumptions that initial position is known to you and initial velocity is known to you. If that is also used, you can fix what is this an and what is this bn, what are these bn's and ans. And that is where we are going to use the theory of Fourier series expansion. Thank you.